guys. Good afternoon. First of all, I think before we start, today happens to be Teachers' Day. So I think happy Teachers' Day, everyone, for all the makers, creators, people who write, read, talk, kind of share their knowledge with the world. So yeah, once again, happy Teachers' Day. And to start off, a little bit about me. So my name is Mohiddin Abdul Qadir Jailany. So I know it's a bit of a long version. So the GZip version is J. So if you guys want to talk chat later, you can refer to me as J. So basically, I love all things web and design. So when I say web, anything related to desktop, mobile, even devices. And I have a specific love for design as well. When I say design, I'm talking about UI, UX, a little bit of industrial design as well. So that's about myself. And currently, I am working at Zolo Space. We are a co-living company. I'm handling or I'm leading the front-end full-stack teams there, building our PWAs, Micro-Frontends, etc., etc. So that's what I'm currently up to. And you can find me on Twitter as Jailany_M, and you can find me on LinkedIn as Jailany Mohamed. Right? So that's about it. And to start with, I think a lot of us would have probably heard about this term already, micro-frontends. Or if you have not heard about this one, we would have heard about its close cousin or probably elder brother, microservices, right? So to kind of get an idea, so before we start diving into micro-frontends, let's kind of understand what microservices are, right? Because the terminology is basically extended from there. So microservices is nothing but it's an architectural style that splits a single large application into a collection of smaller services. Right? That at the end of the day, its name is self-explanatory. That's what microservices are basically. Right? And these services, they should be highly cohesive, which means that they communicate in a seamless manner. They hand off or load off the request from one service to another service in a very smooth manner. And they are loosely coupled. When we say loosely coupled, they don't have any hard dependency on each other. Change in one place doesn't require change in multiple places. And independently deployable, which again, self-explanatory. We should be able to have separate CI/CD pipeline for each of your services, so that if you want to deploy one particular service, you can do it, in isolation without touching any of the other services. And they are usually organized around business context. I mean, like an e-commerce service or microservice architecture would be different from an edtech service microservice architecture. It's all about business context. If you kind of are familiar with domain-driven design, you would pretty much understand how this particular context is organized and everything, right? Let's kind of look at an example, right? Let's kind of take an e-commerce backend, for example. An e-commerce backend, if it's a monolith, it will have all these services in a single application. It will be user management, which is user profile, auth, etc., inventory, discovery, catalog, cart, checkout, orders, fulfillment, etc. So all of these will be in a single monolith. Now, if we want to pull it out and then make it into a microservice architecture, so you will have an API gateway, which will be your entry point for talking to the backend. And from your backend, you will have all these services spread out as different applications or services, right? Now, for a second, imagine that all these backend counterparts, all these backend services have their own front-end counterpart. Let's say that you have a cart service, but there is a UI which is available at /cart. Right? Same goes for orders. There is an order service in the backend, and there is a section in your page where you can go and see your orders. Right? Assume that all of them have front-end counterparts. And again, those front-end services, again, they are highly cohesive. That means that they communicate seamlessly. They work with each other. Again, loosely coupled. That means they're deployed. I mean, like they can work in isolation, and independently deployable, which means that they have their own build and release pipelines. And again, organized around business context, which is very much relatable because they've already taken one backend service and one front-end service, right? So that's together. And one extra addition that we're adding is nothing but they get composed, right? So individual front-end services are of no use if they are all isolated, right? It has to be in a same place or at least under the same domain for us to use. So they are composed together during build time or runtime. Either you can do this at build time or runtime. So if you do this, then you have micro-frontends. That's about it, right? And if you kind of go with the definition, which is an extension of microservices, again, it's an architectural style where you have, instead of a single monolith front-end app, you have smaller micro apps which are composed either at build time or runtime, right? So now, why should you do this? I mean, like, what do you get out of micro-frontends, right? So first of all, the primary advantage, or one of the primary advantages, is that the code base becomes easier to maintain, because instead of having a 15, 20 page bigger application, you will have a 2-page application or a single-page application, which has a concise code base, and it's split into smaller parts, right? So that means that it's easier to maintain code base, whether it's refactoring, whether it's upgrading, etc., any of those cases, right? And next one would be less friction between teams, and this is particularly applicable if you have a distributed team. Let's say that if you have a team working on cart, if you have a team working on inventory, if you have a team working on delivery, so that means that if all of them are working on the same code base, then your releases get blocked, merge conflicts become a nightmare, and especially if how do you say it, if you are moving at a very fast pace, then the trouble gets multiplied, right? So that is one of the major problems with monolith. Now, if you split them into their own business context counterparts, then teams can work individually on them. They can release without breaking other apps or without worrying about other apps, right? And less testing effort and regression. This is kind of a follow-up advantage of the previous one. That means that if you're releasing a smaller portion, that means that you don't have to test the entire end-to-end lifecycle, unless otherwise it's a critical flow change. In most of the cases, you don't have to do full-on regression, thus reducing your testing effort and reducing the bugs that you catch on production as well, right? And this is, for me, this is one of the major advantages, which is ability to choose diverse stack. Now, imagine for a moment that you built a, say, how do you say it? You built a React app, which is a monolith, which has like 15 modules in them, right? Now, when you split them across into like 10 different micro apps, you have the ability, or you have the power to choose if you want to divert from a React to Vue for one particular application because the use case recommends or demands it. You'll be able to do it. You won't be tied down because your existing stack is in React. Doesn't mean that you have to do it in React itself. Or if your existing stack in Vue, doesn't mean that you have to stick to it itself. You have the ability to experiment across, React, Vue, Svelte, etc. Any of the front-end frameworks, right? So you'll be able to do that, right? Now, next steps, right? So we've spoken about what it is and then what do we get out of it. Now, question is that, I mean, like, how do we do this? How can we implement this? So one of the primary answer is that there are multiple methods. You have to choose what suits you. When I say what suits you, that will be dependent on what your application complexity is, what your team structure is, what is your business context is. So it would depend on a lot of things, and it would also depend on whether you are doing it for your customer facing apps or you are doing it for your internal CRMs. Right? That also depends when you make this decision. So we have a couple of methods, and then probably, and I'm going to share what we implemented also, so you guys can make probably an informed decision. Right? So these are the methods that are available overall. So first one is Proxylabs, which we'll see the details going ahead. IFrames, frameworks, web components, and DOM slot rendering. I mean, like, I have to come up with a better name for this. The last one is what we are doing. It's a custom implementation. Name might not sound catchy, so we'll have to work on that. But still, so these are the methods that are currently available to implement micro-frontends, right? Again, when I say method to implement, these are not set principles or set number of steps that you have to do. All of these are more of an architectural paradigm, that how you want to structure your app so that they behave as a micro-frontend, right? So it's not like a syntax or a set of calls or anything. It's not like that. So first one is Proxylabs. Proxylabs are nothing but, I think we might be doing it now also in a lot of cases, right? These are nothing but independent applications running on isolated servers. But the only difference is they'll be served under a single domain name. Let's say if you have, again, an e-commerce platform for an example. Let's say that they have a discovery platform and they have a user dashboard, right? So currently, if you have a single monolith, you will have all of them in the single front end, which will have probably for optimization, you would have split based on routes and everything. But still, they are all in the same code base. They'll get served under the same domain name and everything. Now, if you want to split this into micro apps, what you can do is that you can split them into one discovery app, one checkout app, and one dashboard app. all of them running in, I've mentioned port here because this example kind of points to different node services, or even if you're running different applications, you can run them on different ports, and you can use either your load balancer or your Nginx or Apache to route traffic based on what the user wants, right? At the end of the day, when it goes to the browser, it will be under the same domain name because the routing logic happens at either at the Nginx or ALT level, and you are split everything based on your routes. So when you go to products, that will be a different tab which is served from a different server. When you go to checkout, that's a different tab that is served from a different server. When you go to profile, it is a different tab that is served from a different server. But all of them happen under the same browser window, right? That's all. And you can do this in Docker and Kubernetes as well. If you are running Docker or Kubernetes, you'll be able to do this as well. So this is one of the, how do you say, a primary or a basic implementation of a micro-frontend. Some of the points about Proxylabs are, there is no composition. Composition is nothing but you don't compose apps at build time or runtime here. I mean, like you're just making sure that different apps are served through routing logic. So that means that you cannot have two different apps in the same page. That is not possible here. So, and also allows only one app on the screen. So if you're on products page, that means your product app is loaded. If you go to checkouts page, your checkout app is loaded. That's all. And independent deployments, yeah, that is applicable for this. You can deploy applications independently. And horizontal authentication. So that means that your authentication is either done through cookies or local storage or anything. That is done on the browser level. And no direct communication between the apps. So one app cannot react to the changes in the other app on the same page, right? For primary reason is they are not in the same page. And if you want to share data, then you have to either send it to server and share it, or you put it in local storage and share it. There is no direct communication between apps. Right? So next would be IFrame Composition. IFrame Composition is nothing but you have applications running on different servers again. They might have different domain names or different paths and routes and everything. But when it comes to the page, when it's served, a page could have multiple iframes running multiple apps. So that is what IFrame Composition is. Just to see an example, let's say that again an e-commerce store which has a catalog page, and on the side there is a shopping cart, right? So a catalog page can come from one application running inside an iframe, and shopping cart can come running inside a different iframe. A bit old school, but yes, this is also a method. If you want to kind of do something that is very straightforward, not much of a complex, or if you want to experiment basically, just to see how your users feel about it, then it's a very good way to kind of get started, right? Some points, they can be composed at a page level. So yes, you can have multiple iframes running on the same page. You'll have to configure them based on your route, but you'll be able to do it, and allows multiple apps on the screen. Yes. Independent deployments, yes, and horizontal authentication, yeah, it's the same thing. And apps can communicate through post message. You can send and receive message to and fro from iframes, and then you can probably build a central layer in the window and then pass data between two iframes. And one other additional pointer is whenever you are using iframes, if you're exposing iframes of your application, you have to make sure that you trust the origin, right, where this iframe is called from. This is more of a security thing, but it's a good point to note, right? So that other people can't use your application and run it in their iframe. Fun fact, if you go to your current Gmail inbox, your chat section that is there, right? Earlier it used to be Hangouts, now it's chats. So that chats part in the bottom left corner is an iframe. If you inspect the HTML and then see and find out the iframe URL, source URL, if you open it in a different window, you'll just see the chat app. So even Gmail does this, right? Next one is using frameworks. Frameworks are nothing but certain, how do you say it? Certain guidelines or certain principles that is already set, and these frameworks make it easy for you to bootstrap and configure things easily. Right? Some of the examples are, there is single SPA, which is pretty popular, and there is Front, and there is Luigi. Luigi is recently released by SAP. It's from their open source labs. And some points about frameworks again. So route specific composition, you can compose applications based on routes, multiple apps, yes. Independent deployments, that means that you can deploy your apps independently, yes. And provides lifecycle methods. So these frameworks, they kind of have a central lifecycle methods, so that if you want to stop a particular application from loading at a particular point, but load it at a later point, you'll be able to do those items as well. It's all in their documentation. I've shared the links towards the end. And communication can be through window, or you can create an event bus, or even through shared state if you use Redux or anything. So you can even share states between two different applications. Right? Next is web components. Web components, again, as we all know, custom elements, you can create custom elements and you can use it inside the composing application. So they, in what I would suggest, or how web components differ from all the other items, is that you can even use smaller applications or smaller components as web components. Right? Even if you want to share just a form widget, it is not a full-blown application. It doesn't even have its own page or route or anything. All it has is just a modal window, which you want to share across multiple applications. You can do it through web components. All you have to do is create a custom element, add their own hooks, life cycles, everything, and then you can share it across applications. Same thing allows composition, allows multiple apps on the screen. Here, there'll not be any deployments because you'll be building them into modules and then you'll be importing those modules. So there is only build, right? And good for separating things at widget level. If you want to implement things at a widget level, then that works, right? And communication is again the same because they all live in the same browser window. Right? Now, the coming to the final part, which is the DOM slot rendering, which is basically what we implemented. So it's kind of it's a little bit different from whatever we saw a little bit earlier, but takes pointers from each of them. It's kind of like amalgamation of best of things from all these places, right? So that's about it. Let me start with that. And before we go into what we did, I'll just probably give you a context about why we did that. What was the background behind it, right? So as you guys know, as I said earlier, we are in the co-living industry, right? That means that we basically sell stays, right? So, and that means that we have our own inventory. Our inventory is nothing but a bed or a room, right? And we had an internal CRM, which was a monolith, which was a very big monolith, which had modules like your slot management, inventory, users, KYC, payments, your properties, coupons, etc., right? So it had like 15, 20 different modules, all of them being incrementally built probably like 2-3 years back. And it was built on Angular 1.x. So when it started, it was built on Angular 1.x and it kept growing. So we also were focusing on other areas of our business and everything. We did not pay attention. We were like, this is working, let it work as it is, right? The usual mistake that everybody does. Right? That's what we also did. And this is an application which is used by almost every team in the organization. So you take right from your support team to inventory, your ops team, your ground level team. So this application is being used horizontally by everyone. So that means that this cannot go down. So if it goes down, you'll not be able to onboard users, you'll not be able to accept payments, a lot of problems, right? And maintained by a single team. So yeah, I mean, like there was a team of 2 or 3 people who are kind of adding features, maintaining a release cycle, etc., etc. And they were also just hosted in as a normal application in EC2. It was just running, right? It was okay. It was all good until it wasn't. At one point, it wasn't. Right? The reason for that is because when business started to grow, there were new modules and features, requests that kept coming in. And as we all know, right, everything is kind of needed yesterday when it comes to business. For business, everything is needed yesterday. So we were not able to kind of go or run along with the same pace as the business. So because when we say that, we want to make this change, but for this, I need one full day of QA effort to test everything else works fine. That's kind of a no-go, right? So that is one thing. And because of this, we started making more releases without proper testing. That means more production bugs. That means, again, comes back and then bites us in the back. Right? That's about it. And language fatigue. I mean, even to migrate from Angular 1.x to 2 or 5, that itself looked daunting. Right? And people were also kind of, it was not a good experience overall. Language fatigue, it's not a good experience. So what we decided was we were like, let's do one thing, let's rewrite it. Right? And probably one good thing that we did while rewriting is that instead of rewriting that again into a monolith in a newer or a latest language or a framework, what we did was we split them into multiple apps. Let's kind of split things based on whatever microservice backend that we have. Let's build front ends for those applications and then combine them together. So the reason for building into separate apps is nothing but We get more control, smaller apps, independent releases, and the ability to experiment with frameworks. This is basically the advantages that we saw earlier. Right? Now, let's look at how we did it. So these are the 4 major steps. Right? So one is you have to split the apps. That means that one feel good factor about this is like all of these are again done from or created from scratch. That's always a good feeling for an engineer. Right? And first thing is split the apps. That means that you have to make a logical split of what are the contexts or what are the modules that you're building into separate apps, and then build them separately. Here, build them separately means 2 different contexts. One is build is actual engineering, and another build them separately is deploying. So build and deploy separately. Okay. And creating a composing layer, that means that you have to have a central layer which will compose applications and serve it to the end user. The end user shouldn't know that these are coming from different applications. They don't have to know that. For them, it's a single application, right? And render the apps based on configuration. So whichever route that I'm in, that means that, okay, this route needs 2 different applications to come in and sit in this layout, then render those applications. If a page requires 3 different applications, render it properly. So that's how we render it. Now, if you think about it, the first and second steps are pretty easy. That is what we do on our day-to-day lives. We build smaller applications and we build them, right? The difficult part was the last 2 points, creating a composing layer and rendering the apps based on config, right? So that was the difficult part. Now, looking into, again, detail, right? So splitting the apps. So how we did split the apps is you have to make sure that your apps are smaller. That's the primary point of this. So we made sure that our modules are smaller enough to kind of fit them into kind of like a 3 route, 4 route applications. I wouldn't say page because they are building SPAs, probably 3 or 4 routes, nothing more than that, right? And split based on context or service. You have to make sure that your splitting logic reflects your organization or your tech orgs or your backend orgs structure. It has to reflect that. Otherwise, you will have very much a lot of difficulty in even getting APIs ready for them. Right? So you might build a service out of the blue, and that service might not have a proper backend counterpart. So you'll get in trouble with backend saying that where should this API come from? From which service should this API come from? That will become a problem. So you have to make sure that your blueprint should kind of superimpose very clearly with your backend architecture, right? And has its own BFF. BFF is nothing but backend for front end. They are done in such a the reason because they give you additional layer of security, right? You, instead of calling your backend services directly, you call your BFF first, and your BFF filters out unwanted requests at that level itself, and then sends only valid requests to your backend, and then comes back in everything. So that's one reason for us to use BFFs. And bundles are pushed to S3. So we did not deploy them in a server using Node.js or anything directly because I mean, ideally there was no need for it. If we had a server rendering or requirement or anything, we would have probably done it. But this is internal application, we did not need it. So what we did was like our bundles which get built are pushed to S3, right? That's all. And when you build these applications, we had to set a couple of rules. These rules are again put in place so that your composing becomes easier, right? So first one is your public path to be set through your S3 URL. Imagine you have an S3 bucket, and then inside that bucket you have different folders, one for your app 1, app 2, and app 3. That means that your app 1's bundles should have a public path as S3 URL / your app 1, right? The major reason for doing this, or one of the reasons for doing this, is because so that your static assets get served properly, and if you're lazy loading things at route level, your secondary chunks can also come properly. You don't have to worry much about implementing that part. This is taken care of in an inherent way by React and Webpack itself, right? So that is one thing. And second one is the bundle should have an asset manifest. Asset manifest is nothing but when your application gets built, you have a list of files that pass through Webpack. They get generated as a manifest file as a JSON, and you get it in output. So this is also required. We'll see why it was required in the upcoming steps. And DOM slot should be unique. So that means that, again, hence going back to the name DOM slot rendering, that means that if you have 3 different apps, the DOM ID that you're injecting your application or hydrating your application into, they should be unique. So if I have a header app, a catalog app, and a sidebar app, each of them should have their own unique ID. So here in this case, if you can see the code snippet, here we hydrate the app by taking the app component and putting that inside a DOM element which has an ID sidebar, right? And this ID should be unique, right? So these are the set of ground rules. And next step is building a composing layer. Now you've split your applications, you've built them with the given rules and proper restrictions and everything, and they all live in S3, right? So you have a bundles that is living in S3 in different folders, and you have your asset manifest which tells you which application requires which files, and then you have a unique DOM slot where this application is supposed to be injected. Now the next logical step is to make sure that we get all of these things together and then render the page, right? So for creating a composing layer, we used Node and Express and Handlebars. Handlebars is nothing but a templating engine. You can probably use Nunchucks, Jade, any of them. So they all work very seamlessly with Express. And we use wildcard route matching for apps. So that means that the entry point for my application would be something like www.something.com/app/1234. So that 1234 is basically my wildcard route, which I'll take and then use it to fetch my configuration. So each page will have a configuration that is stored either as a flat file JSON, or probably it could be in the DB based on the level of complexity of the configuration that you require. And you fetch the configuration, and our Express app, it renders the templates based on that particular configuration. Now, if you look at it, there are two levels of templates. One is root template, another one is page template. The difference between root and page templates are, your root template is nothing but your skeleton HTML, right? It could be your common links, common CSS, or common JavaScript, along with your specific JavaScript and specific CSS files. And your how to say, you have a placeholder for your page template to come in. So if you can see the snippet on the left side, you can see that inside the body tag you have a triple curly braces body. That means that is the placeholder where page level templates come and sit in, right? So this gives you a capability where if you want to do things at a common level, you can do it at root level. If you want to do things at page level, you can do it at page templates. And on the right side, if you see, it's basically that you have your page templates. Page templates do nothing but they render an empty div with a given DOM slot. That's what it does. And the DOM slot also comes from your config. So if you think about it, you have a config which says that I want to render a header app, which has a DOM slot name as header. Then the composing layer should just render an empty div with an ID called header, right? So that's all at this step. Now, to kind of look at the route configuration, this is just a sample format. You can extend it or modify it to suit your needs. We have first one is home and cart are pages, or basically routes, my wildcard route, and I have my apps inside them, which means that what are the apps that I want to load inside this page. If I'm in home page, I want to load 3 different apps. One is a catalog app, second one is a cart app, and third one is a header app, right? So each of them have their own DOM slots and they have their own source URLs. Source URLs, as you can see, it's nothing but your S3 folder URL, right? So that's about it for now. And communication between apps. So let's say that we have rendered all the applications and the page and everything. Now let's say you have to communicate between these two things, right? How we did that is basically that we implemented our own PubSub logic. Basically, we call it as event bus. So PubSub sits on the composing layer where apps can publish events with data, and whichever other apps on the same page, if they want to listen to that particular event and then use the data, they can do it. A simple example could be left side where you have your products, on the right side you have cart. Whenever you click on add to cart, you throw an event saying that add to cart, and then the data of the products. The app that is listening to this particular event will update the cart page, right? So that's a very straightforward example. Yeah, that's about communication. And yeah, before we get into the code and I've prepared a small demo for this. So before we get into that, I'll just walk you through the request flow, right? Whatever we discussed in different slides. Our request flow goes like this. Let's say your client requests a page called /cart. It comes to the server. server pattern matches and then finds out that the user wants the route card, right? And from the JSON or from the DB, it will fetch the configurations. And in the configuration, you have your S3 URL. And from the S3 URL, you will fetch your asset manifest. And asset manifest will have your CSS and JS files that is needed for the first load. So you will fetch those things. And you will add those CSS and JS as, it's not imports. Basically, you'll add link tags for your CSS files and script tags for your JS in your root template. And from root template, you'll go to page template. In page template, you will render a single div with an ID cart because you want to render, or not a single cart. Basically, if you want to render 2-3 apps, you'll render those many IDs. And then the markup is sent to the client. So that means if you look at it, the current markup has a skeleton HTML, which has all the CSS and JavaScript files added, and a page level template, which has 1 or 2 or 3 divs based on the configuration with unique IDs. It might have a header, it might have a catalog, it might have a cart, right? And then this markup is sent to the client. And when client loads, it will load the CSS files, do whatever it does, and then it will load the JavaScript files. And once the JS bundles are executed, they'll know that each of the application that gets executed individually, they'll know that, okay, I'm a cart application, so I have to go and find a div called cart. I just have to inject my HTML into that. Same thing will be done by header. Same thing will be done by the other application that is there. And once everything is, if the styling or the layouting is done at the app level, so that means that your cart will come on the side, right side, your header will come on the top, and then applications will be rendered, right? And the content will be loaded into your divs. Once everything loads, your page will look as if it is coming from a single code base or single server or single application, right? So this is the request flow, and I have a sample code and demo. I'm really sorry about this. I don't have a very detailed demo or anything. I had to prepare it in urgent, but it will kind of explain the overall architecture of what we are trying to do. Right? So now let me just show this, right? So here you guys can see that this says that this is the header app. I have a header. I have a main app. I have a main app, and then I have a sidebar app. So all of them, as of now, if you look at it, all of them look as if they are, coming from a single application, right? And here I have all of them running in 3 different dev servers. So this is the header app. Whenever I make changes to header app, this gets updated. And this is my main app. This is also running separately. And this is my catalog or sidebar app. So this is also running separately. Now, when I go to my node server, which is the composing layer, and go to the route called home, which is supposed to render all 3 of them, it renders all 3 of them together, right? Now let's see the source, right? So if you look at the source, you'll see 3 empty divs, which are basically your header, catalog, and sidebar. And I don't have any CSS, that's why there are no CSS files. And all of my individual JavaScript files for each of these applications, they're loaded here, right? There are problems with this. We'll discuss that in a while. So what are the problems that come with this method? But before that, let's go through the code ones, right? So I'll probably walk you guys through the code. Client apps are pretty much similar. I don't have to kind of talk much about it, but just to kind of understand, it's just a header component, has its own style, how it should be rendered and everything. And it just says header app. And one primary thing is when we are rendering things into our applications, we use the header, whichever DOM slot that this particular application should be injected, this has to be correct. Here, if I say sidebar, then header app will load inside sidebar, which we don't want. Or probably they'll clash between whichever one loads for second, it will override the previous one. So we don't want that. So even the sidebar or catalog app, all of them have similar structure. And probably one more thing which I can show. Yeah, I think that's about it from here, right? The primary layer is my composer layer, right? My composer layer is built on Express, which has handlebars as my templates. I have a couple of helpers, and I have a router. So my root/apps is my base route, and if I go inside my router, I have a parameterized route which takes whatever that comes here, and I have a couple of middlewares. Right now, these middlewares does the job of the steps that we saw in the flowchart. Right. So basically, if I go to get route data, which is nothing but what it does is it finds the current app route, which is basically in our case, if you look at the example, it's home, right? And it will try to find out what is the configuration. So I have a sample configuration here, which is basically home. Home has 3 apps. One is catalog, one is sidebar, one is header. All of them are hosted here in a S3 bucket inside 3 different folders. They will have their own bundle files and asset manifest, right? And where was I? So yes. So I'll have my route config, and from my route config, I have to fetch my asset manifest. And once I get my asset manifest, or probably we can look at how the asset manifest looks also. Looks like also for this case. Let's take sidebar for example, right? So no, I don't have direct browser access. It's fine. So cool. So I'll have my own. Each of these applications will have its own asset manifest. In this case, asset manifest will contain 2 files: one main bundle and one chunk bundle, right? So that's all. And using that, I'll create my configuration, which is but nothing but I have an app name and what are the files that are needed. Once I get the asset manifest might have a CSS file and a JavaScript file also. I have to separate them out into 2 different arrays so that you can render them differently. So those go into files, and then I have my DOM slot. DOM slot again comes from your config, and you have your source URL. Source URL again comes from config, right? Now, if you look at it, once all these things are loaded, I'll put the data in my request locale, and then I'll pass it to my next middleware, which is nothing but my renderer, right? So a render does nothing but it renders a template called home, right? Now let's go and see inside home. Inside home, I run a loop for each app, right? And then I print 3 or not 3, I mean, how many ever apps that are there, we print that many divs. Here, if you look at the config, there are 3 apps. That means that in your template, there'll be 3 different divs. Each of them will be catalog, sidebar, and your header, right? That's exactly what we have here. Catalog, sidebar, and header. That's exactly what we have. Now, to the place where we put the CSS and JS files, right? They come from root template, as we saw. So that means we have a skeleton HTML. And here, what we do is like we again loop through each app, and then inside apps, we send a array called files, which had CSS files and JS files. So we loop through each CSS file. And then we have a helper. Helpers are nothing but smaller functions used to render content on the page. Here it will do nothing but it will see whether your file is JS, then it will render a script tag. If it's a CSS, it will render a link tag. That's about it. Right? And when you come here, this particular widget renders your CSS files. This particular widget renders your JavaScript files. And once all of these things come together, they get they get executed, and then they get added to the page. Right now, where were we? Yep. So to come back, right? So I hope you guys understood. We can connect later if it was too, I ran ahead too fast. But still, so coming back, this helped us compose applications based on route config and everything. But there were challenges. So challenges on sharing components. Let's say that if you have a single unified language that you want to share across applications, that becomes a problem. So you might end up creating a component library. That's one way to go. Or other way to go is use Material UI or and design or some framework. That works for internal applications, not for external applications. So yes. And another challenge was building this configurable composer. The demo looks simpler, but the actual configuration is much complex, and it comes from the DB. So modeling that and then making that editable and then giving that UI to business teams, that is one challenge. And making sure our authentication and authorization. That is also one challenge, because we don't want to do it again and again multiple places, right? You have to keep it central as much as possible, so that if there is any change in the future, you don't do it again and again. That's one thing. And effective communication between apps. Earlier, this was also a difficulty, but once Event Bus came into picture, that became a breeze. that's about it. And what's next? So we have not cracked server rendering with composition yet. So that itself is a unique challenge. So that is something that we are working on. And another one is module federation, which is coming up with Webpack 5, which is nothing but you'll be able to share bundle from one app to another app. This will solve the problem of sharing components between apps. It means that you don't have to maintain a central repository of components. You can start building as you go and then harvest things from there. So that will be one very good thing. And performance and size. Now, in the example that we saw, also React is loaded 3 times because it's present in each of those apps, right? That itself is a problem. You might have to put it on externals or load them separately and everything. So those optimizations are they come up once you face those problems. These are not very straightforward problems, right? So those are the next steps. I think it's not just for us, for anyone implementing micro-frontends. You'll run into all these items. And yeah, I have a couple of references here. And yeah, one more thing which I should have probably said in the beginning. So even though I have been in the industry for quite some time and then participated in panel discussions, open discussions, this is my first proper talk at a meetup, right? So if you guys have any feedback, I'll share the form link in the chat as well. Please feel free to give your feedback, right? So that I can improve on, right? So that's one thing. And thank you. And any questions?